Welcome to Lesson 7. What Lesson 7 is about is how chemical reactions can absorb and release heat. Not just hot metals, but actual chemical reactions. We'll also be able to use energy diagrams to represent enthalpy change in reactions. So enthalpy is a new keyword that we're going to have today, and obviously we've never seen energy diagrams either, but I want to show you what they look like. This is what an energy diagram looks like. It's kind of a mathematical diagram, but not really. It's more to represent an idea. So by the end of the lesson, we should know what these mean. Now, as always, it's always good to start with kind of reviewing what we've learned. And today, we're not going to put a hot metal into water. We're going to put a chemical, calcium chloride. So I'm going to put a little calcium chloride into a beaker. And we're going to let it exchange heat with water just like the metal did. Now what's interesting about this is you notice there's no stove here. We've left my stove top. And the water and the chemical, the calcium chloride, are at more or less room temperature. You notice that my water's a little bit cold, but they're more or less at room temperature. Yet when we pour the chemical in there, we will see a change in temperature. But we're going to do more than one chemical. That's the reason why I paused it here. We're going to do calcium chloride, which is this white chemical over here, the one that you were just seeing a moment ago. But we're also going to do ammonium nitrate. And you notice they look really similar, but they aren't the same chemical. Now, of course, they're going to do two different things here. We're putting them both into about room temperature water. The chemicals themselves are not hot or cold like the metal was hot, yet we're going to see a change. So what I want you to do on your paper is I want you to record what the initial temperature was of each one of these. I want you to record what the final temperature is as this runs through it. You don't have to worry too much about it, because if you stop the video here and record the initial temperature, when it time lapses, you can just wait to the end and kind of see what those temperatures are. So you should not feel stressed about watching two videos at once. But then I want you to make a prediction. Which one of the reactions that's going on here is endothermic and which one is exothermic? And try to come up with evidence that would support your reasoning. All right, I'm going to start this one, and I'll start this one. Don't forget to record the data, and then make your prediction. I think they're both getting close to the end, so when they stop, you can record your final temperatures. But when I say, are the reactions endo or exothermic, I'm not talking about, let me get this one back for you here, I'm not talking about the water, I'm talking about the white powders. Are the white powders absorbing or releasing energy? All right, go make your prediction.